My name is Sriramu. The topic is properties of Fourier transform. Properties of Fourier transform. There are 11 properties of Fourier transform. First one, linearity, superposition, time scaling, time shifting, duality or symmetry, area under x of t, area under x of f, frequency shifting, differentiation in time domain, integration in time domain, multiplication in time domain, convolution in time domain. There are 11 properties of Fourier transform. Linearity superposition. If x1 of t is equal to x1 of f and x2 of t is equal to x1 of f, then a1 x1 of t, a2 x2 of t is equal to a1 x of f plus a2 x of f. This allows directly from the definition of the Fourier transform. Our integral operator is linear. It is easily extended to a linear combination of an arbitrary number of signals. Second one, time scaling. Time scaling, let x of t and x of f be a Fourier transform pairs and let alpha be constant. Then time scaling property states that x of lambda t is equal to 1 by mod lambda x of f, x into f by lambda. X of lambda t represents a time scaled signal and f by a represents frequency scaled signal. If lambda greater than 1, x of lambda t represents compressed signal, but x of f by lambda represents expanded version of x of f. Where lambda greater than 1, x of lambda t will be an expanded signal in the time domain, but its Fourier transform x into f by lambda represents variation of x of f. Next one, time shifting. The time shifting property states that if x of t and x of f form a Fourier transform pair, then x of t minus td is equal to e power minus j 2 pi ft d into x of f. Here the signal x of t minus t naught is time shifted signal. It is the same signal x of t only shifted in time. Duality or symmetry. This property states that if x of t is equal to x of minus f, then x of t is equal to x of minus f. The duality theorem tells the shape of the signal in the time domain and the shape of spectrum to be interchanged. Area under x of t. The property states that the area under the curve x of t equals to value of its Fourier transform at f is equal to 0. Example, x of t is equal to x of f. Then x of t is equal to x of 0. Area under x of f. This property states that area under curve x of f equals to the value of signal x of t at t is equal to 0. If x of t is equal to x of f, then x of 0 is equal to x of f. Frequency shifting. The frequency shifting characteristic states that if x of t and x of f form a Fourier transform pair, then e power j 2 pi fc power t into x of t is equal to x of f minus fc. Fc is a real constant. Difference in time domain. This property is applicable if and only if the derivative of x of t is Fourier transformable. D by dt of x of t is equal to integral 2 pi of x of f. Integration in time domain. Integration in time domain is equivalent to dividing the Fourier transform by j 2 pi phi. If x of t is equal to x of f and provided that x of 0 is equal to 0, where integral minus pi to t x of lambda into d lambda is equal to 1 by j 2 pi f into x of f. Multiplication in time domain. The multiplication theorem states that if x1 of t is equal to x1 of f and x2 of t is equal to x1 of f, they are two Fourier transform pairs. Then x1 of t into x2 of t is equal to x1 of t into x2 of f minus t into dt. This means the multiplication of two signals in time domain gets transformed into convolution of their Fourier transform. x1 of t into x2 of t, then where x1 f into x2 of f. Convolution in time domain. This property states that the convolution of signals in the time domain will be transformed into the multiplication of their Fourier transform in the frequency domain. Example, x1 of t into x2 of t is equal to x1 of f into x2 of f. There are 11 properties. Convolution in time domain, multiplication in time domain, integration in time domain, and differentiation in time domain, frequency shifting. Frequency shifting is e power j2 pi f c of t is equal to x of t is equal to x of f minus fc, where fc is a real constant. In area under of x of f, x of t is equal to x of f, where x of 0 is equal to x of f in the area under x of f. And duality or symmetry. Time shifting. The equation is that x of t minus dt is equal to e power minus j 2 pi f t of d into x of f. Here the signal x of t minus t is a time to shifter signal. Yes, the same signal x of t is only shifted in time. And time scaling, linearity, superposition. There are 11 properties of Fourier transform. Thank you.